Find the potential difference between the point A and B and point B and C of the figure as shown. Now in this question we use the concept that at steady state all the capacitors act as an open switch, that is, no current flows through the capacitors at steady state. Now even let's say that current I flows at steady state, then clearly in the circuit we don't have any path through which the current can flow completely and comes back to the battery. So I assume that the current flowing will be equal to 0. Now to calculate the charges on each of the capacitor, we reduce the circuit a little bit. We have this 3 microfarad and this 3 microfarad in parallel, so the resultant will be 6 microfarad. So let's simplify the circuit. We have another capacitor like this. This capacitor is the resultant of 3 microfarad and 3 microfarad in parallel, so the resultant is 6 microfarad. We have 1 microfarad and 1 microfarad in parallel again, so it gives me 2 microfarad. Let's say this point is my B, straight line coming down. Another, we have 1 microfarad like this, and this is my point A, this is my point B, between which there is a resistor, a battery, and then another resistor of 20 ohm, 100 volt and 10 ohm. So this is my reduced circuit. Now clearly a 100 volt supply is applied across 1 microfarad, so I'll use the formula Q is equals to CV. I have capacitance as 1 microfarad, voltage is 100 volt applied, so 100 into 10 to the power minus 6 coulomb is the charge on 1 microfarad capacitor. That is the charge on 1 microfarad capacitor. Now to calculate the charge on 6 microfarad and 2 microfarad, I have to calculate the resultant of 6 microfarad and 2 microfarad first. Let it be C dash equivalent. So it will be equal to 6 into 2 divided by 6 plus 2. That is the series combination of the capacitors, comes out to 12 by 8 or 3 by 2 microfarad. So the charge on 6 microfarad and 2 microfarad is again calculated by formula Q is equals to CV. Net capacitance is 3 by 2 and voltage is 100. So charge comes out to be 150 microcoulomb. That is the charge on 6 microfarad as well as on 2 microfarad. Now applying the Kirchhoff law from A to B, I can write potential at A minus Q at 6 microfarad divided by C of 6 microfarad. That is the potential drop across 6 microfarad capacitor, and that is the potential at B. So VA minus VB equal to 6 by C, both for 6 microfarad capacitor. On substituting the value, I have Q as 150 microcoulomb and capacitance as 6 microfarad, which gives me the answer 150 by 6, which on solving I have 50 by 2 or 25 volts. That is my answer to the first part. Similarly, to calculate the potential difference between the point B and point C, I have Kirchhoff law, VB minus VC is equals to Q by C, and this time for 2 microfarad capacitor. So charge is again 150 microcoulomb and capacitance is 2 microfarad. So answer comes out to be 75 volts. That is the answer.